Okay, this is called completing the square when a is not equal to 1. What are you talking about, Mr. Server? All right, I'll tell you. First off, here's one where a was equal to 1. Now, let's make it 8. Was 4 the ideal number to put right there? No. What would have been the ideal number to put right there? 16. All right. So let's go with y equals x squared plus 8x plus 16. Can you just change a 4 to a 16? No, but I can just move the 4 over and still say it's over here. This is what we did the other day. And by adding this 16, we also had to subtract 16. That kept it balanced. Final answer, this part factors now. This part simplifies to negative 12. There it is. Boom. Basically one long step, and I've got what form changed into what form? Vertex. General changed into? Vertex. Excellent. Okay. And why is this good? Because the vertex is handy. It tells you the minimum. It tells you the maximum if it's flipped upside down. It tells you the axis of symmetry. It tells you where the thing's increasing or decreasing. There's so many things that are good about the vertex. All right, so what are we doing today? Let's go back or on to the next page, this piggy pink page. All right. So look at this one. What's different about this one than one we had ever done before? There's a 4 in the front. That's the A term, and we haven't ever had a number there before. So this is going to freak some of you out, but watch what I do. The argument would usually be, you can't factor out a 4 because there isn't a 4 in the 17. But if you multiply back out what I have here, I forgot a squared, sorry. That times that makes this. And this times this makes that. And then this is that. So they're equal. Okay, so then why would I want to do that? Because now I can just go through my normal little half and square thing. Where I go, gotta erase this. Plus, and then half of 4 is 2. 2 squared is 4. And then if I do a plus 4 there, I got to do minus 4 here. See how the plus 4 and the minus 4 are going to cancel each other out? But wait a minute, they're not. Why wouldn't those cancel each other? Because this 4 is going to hit that 4 and turn it into a 16. So 16 and negative 4 don't cancel each other out anymore. That was this whole role of this guy, was to cancel out that guy. They better cancel each other out. So I have to times this one by 4 also to make that negative 16. We'll cancel off this positive 16. There. That's the most complicated step. Everybody knows how to factor. The only thing weird is you're not factoring it out of the last number. There's a y equals at the beginning of this whole thing, if that's what you're talking about. All we did is factor out a 4. Then we had to realize that this number was going to get multiplied by this 4, and that means we better scale up this negative 4, also multiply it by 4, so that it'll all end up canceling. But all we've done is given ourselves, we followed all the rules. When we added 16 by putting these two 4s in, we subtracted 16 to cancel it, and then your final answer looks like this. And positive 17 and negative 16 makes plus 1. There we go. That's vertex form. All right, another one. I think the best way to do this is by actually doing some problems. This time, there isn't a number in the front. There's a negative in the front. But couldn't you argue that that's a negative 1, and that makes a number that's in the front? Yeah, you could. So then that means you could factor that out. After only seeing one example, do you think you could do it? It's going to be a stretch, but everybody give this a try. See if you can factor that 1 out. Then you do half and square. Then you got to remember whatever the half and square number is has to be canceled out by its exact opposite. I'm going to pause for just a second. I know this is a stretch, but if you don't know how to do it, at least you'll know where you're getting stuck. And for the few of you that actually can pull this off, bravo. All right, so let's see if you caught on to that. What's in both of these? You only factor out the -1 from the first two. I know some of you were tempted to factor it out of the 94. Don't. Why? Because that 94 is going to be way over here, and it's not going to be inside the parentheses where this -1 will take effect. Okay, so then this is going to be x squared minus 20x. And then this is a classic mistake I just made. I didn't leave myself room to put in my half and square number. So now I got room for it. Half of 20 is 10. 10 squared is 100. It's always positive because it just got squared. Now, if I put a -100 here at the end, I just goofed up. Because this will be -100. So to cancel it, it should be a positive 100. You always got to look that this number and this number, after it gets multiplied by this number, are going to cancel each other out. So then final answer, if you caught this, I'll be impressed. -1 parentheses x minus 10 parentheses squared plus 6. Anybody pull that off without any help? Nice, about half of you. All right, now let's actually answer the questions this time. Vertex form, well, that's that. Vertex, that's 10 comma 6. Notice I use the opposite of the number I see here because it's on the inside, so you don't trust it. Max or min. I know it's upside down because of this negative here. So if I picture any parabola, well, actually, why not do the exact one? Over 10 and up 6 is a dot like there, and this has got a negative in front, which means to me that it's upside down. And then, is it a max or a min? When I see the picture, it's obvious it's a max. Domain is all reals, and you can write that with a big R. Notice there's 2 straight up and down lines on that. Big R. Okay, the range. From how low? Well, it goes down forever, so that's -infinity. To how high? Of the two things, this is the height. I'd say I marked the range wrong more than anything else, because people get confused. And if once you see the picture, you guys are probably like, well, it's so obvious. But when you see the picture, it is obvious, but people don't make the picture. Yes?
For the 6, would it be a bracket? Is it?
Ooh, you might have got me on that one. Okay. Does it touch 6 is the question. And yes, it does touch 6, so you are absolutely right. There's a bracket right there. Okay. This one. I think we should get up to more than half the class to do this one. Last time we got half the class without any help. Let's see if we can get up to 3/4 of the class on this one. Hint, don't mess with the 40. Start by factoring. Okay, let's give this a try. The 3 gets factored out. You have x squared minus 8x, and then 3 can't come out of 40. Even if it could, I wouldn't touch the 40. I'd just move it to the end. Then I have a parenthesis here to leave myself room to put in the half and square there. Half of 8's 4. 4 squared, 16. Changing colors. Plus 16 and a minus 16. But wait, this one's going to get hit with a times 3. So this one has to be hit by a times 3 to cancel each other out. Then y equals 3 parentheses x minus 4 squared 40 minus 48 -8. And yay, I've got my vertex form. Raise your hand if you had that. Sweet, it's almost everybody this time. The vertex was 4 comma -8. If I make a quick picture, it's 4 to the right, down 8. And it's a U shape. So it looks like that. Then that's a min. Domain's all reals. And the range is from there up. So what's there? I got to take the y of it, which is -8. So -8 to infinity. Can it be -8? Yes, it can touch -8. Bracket, parentheses. There we go. All right, last one is to start the Schoology quiz. I did one more in the other class, but I think you guys are good. So, if you get stuck, come up and ask. There is a Schoology quiz, and about 9 kids finished it before the end of the hour. I'm giving you slightly more time than them. So, try to crank that puppy out. You can be done with your math. That's all I have for you for the video for today.